And we are live. Hello, everyone. It's Will Middleton from LifterLMS, and today I'm joined by Christos from Pressidium. You might recognize him from another webinar we did recently around decrypting and decoding hosting in WordPress and helping myself and other LifterLMS users understand what hosting is, how it works. And so check out that other stream we did a while back. We'll have a link to that in the description here. And today we're going to be diving into hosting, LifterLMS, and Pressidium. And we're going to be taking a look at speed and how many concurrent users you can have on the LifterLMS website that's hosted on Pressidium. Christos is coming in from Athens, Greece, joining from Athens, Greece today, and I'm in Berlin, Germany. And so, yeah, we're going to be diving into a couple of tests around benchmarking, capacity planning, and where you should put an application on what hardware, because we talk a lot in WordPress about the software and the plugins and themes aspect of things, but the hosting is like the fundamental layer that is the application itself, the hardware running your application. So it's really important to understand how these things work. And so I'm super excited to have Christos joining me today to demonstrate some of the hardware aspects of running a successful WordPress website. And we're going to be working with a fresh WordPress install with no users yet, but we're going to be using the LifterLMS core plugin along with all the add-ons installed and a clean database. So thanks so much, Christos, for joining me. You want to take it away?
Yeah, thanks for that great intro. I have nothing else to add to the intro. I was just about to make my own, but there's no point, I guess. I'll go straight to sharing screen. So performance. Everyone talks about performance and websites. There are quite a few different types of performance. Let me share my screen.
Yeah, that's like you said, performance.
All right.
Yeah.
So what performance like really generally revolves around are these four like cardinal, I don't know, metrics, cardinal key points for me. So reliability, does it always work? Always is in italics because nothing always works. Stability, does it always work well? Speed, is it fast or is it slow? And scalability, what we can do to sustain performance or sustain speed and still be able to manage more parallel concurrent users, or anyway, have a lot of traffic on your website. So far, so good. Just like a general concept of performance before we get into what performance testing is, what kinds of performance testing there are, and so forth. What do you think?
Yeah, so that makes sense. To me, like performance is obviously something that we use all the time when we talk about plugins, themes, hosting. And so I really like how you break it down. So there's like, what you're saying is there's four different main kind of components that we take a look at with testing for performance and what performance really means. Is that?
Yeah. Okay. I can give a really long, boring example here. I mean, I try to do it anyway. So I have this like nice story about a real world scenario about you're finding yourself in the midst of the festive frenzy, maybe Christmas or whatever other holidays around the corner, and you go to the grocery store. I'm sure it's happened to you. It's happened to all of us at some point. So you get there, you can't find enough. There's not enough parking space. You can't park anywhere. There's that scalability.
Okay.
What else? Speed and scale, the number of customers in the store's layout, the way the store is organized, all these things can add to, I don't know, customers running around and causing havoc rather than actually, getting their products and going to the checkout and actually going home. A long checkout line would be something else too. I guess I would have addressed stability or, no, not stability, but scalability. Stability would be something like, is your LifterLMS plugin up to date? Is it stable? Is it good? That's going to affect performance too, because with every new, I don't know, maybe not every new, but with every update, there usually are performance benefits, aren't there, from your end? That's what I see in my testing.
Yeah. Yeah, there's a lot of emphasis on performance and how like optimizing how we store things and serve things from the database to try to make it a bit more performant in the terms of scalability and stability.
Yeah, that was a big project on your guys' end. I remember when you guys were trying to not use the stereotypical meta table method or approach. Good work on your end.
Yeah.
So going over that, and that really like bad example of that story, I've written it down. I'm going to make an article eventually. Sometimes it'll be better than it was. So
nice.
I'm trying to go to the next slide, but my mouse is disagreeing with me. Two types of performance testing. So I think everyone's more familiar with front end performance testing, the browser based, the one that's at the bottom. So I'm going to do this back upside down. That's everything everything that uses Lighthouse, for example, that uses metrics like first contentful paint, LPC, the speed index, page speed insights is a really big and like vital tool for those kinds of performance optimizations or performance analysis. GT metrics is another really good example, and web page test. We're not going to look at that. That has to do with how the browser interacts with the website, how things load on the browser, how the browser renders things. And that has to do more with, I think, well, all of performance does, but it has to do with user experience. We're going to talk more about protocol-based server-side performance testing. What happens there is you have some sort of testing engine that simulates or tries to simulate a real world scenario with multiple concurrent virtual users accessing your website. The main components are a test plan. You have to tell the engine what to do. So it's like a user journey. An example of a simple user journey would be someone goes to the homepage of your website, they log in, they go to maybe it's an e-commerce website, so they go to the product catalog, they select the product, add it to the cart, and check out. That whole thing, that user journey, you can you can take that and insert it into the testing engine so that it simulates everything the user does, including so with LifterLMS, when you go to take a quiz, there's a little progress recorder. It's a little post it's a little request that goes from the browser to the server hosting the LMS website that writes or records your progress on the test. You don't see that happening as a user, but that's one of the things that we do look at and we test with protocol-based or server-side testing, performance testing.
Okay, so I'm trying to understand that a little bit from like an abstract point of view. With so is it like a log where you're like simulating certain activities, or you define what these activities are, and then you basically have a server mimic these activities by just pinging the or so I guess, are you having like an external server just ping your website server with a bunch of requests that mimic user behavior in order to test this kind of speed and performance, or is that? Oh, okay.
So in a nutshell, that's what happens. The attacking part, let's call it that, or the attacking party. Then all the information has to be taken back and collected. So then there's the data set. All that information is usually time series data. So it's always something that has to do with that's in relation to a certain time. Like at this point in time, this happened. At this point in time, this happened. The main metric we focus on that we're going to see live, so I'm not going to go too deep into all of that, is response times. That's what we really care about at the end of the day. We want to see how long it took to make this request for LifterLMS.com.
Okay.
And how that changes over time and with increased stress on the server. So by increasing concurrent users, a thread of concurrent users just means more requests. But it's literally another user going through that same test plan, that same user journey over and over. To simulate it, there's always think times, there's always random pauses. If it wasn't for benchmarking purposes and you were trying to do capacity planning, for example, I would ask for a legitimate user journey, what your users actually do on the website. And I'd like to go into Google Analytics. I'd like to see how many hits you have. There's a bit more, I don't know, art to it. But for benchmarking and capacity planning of the nature that we're going to do today, we're not going to go into that, how to collect the information for the user journey so you could make it as good of a test plan as possible, because it's impossible to simulate real world traffic.
Right, because everyone's going to be kind of doing a little bit of a different thing. You might have people on the blog and like a bunch of people going to a blog post that was promoted on Instagram at the same time. Some people are taking a quiz or whatever. So you just try to form like as accurate as possible in a real world scenario. But here today, we're going to be just kind of mimicking a general LMS user experience that we defined.
Yeah, and that brings us to like our first objective. Before starting any tests, you want to get your objectives out of the way, right? So your first objective is going to be, I want to optimize the speed of my homepage. So PSI gives me a better score, and then I can have better results from the Chrome user experience. That's an objective. You can't just say my site's slow, or for maybe the protocol-based testing that I'm referring to now and that we're going to display, You could say, I'm expecting a surplus of traffic before Black Friday on my website, and I want to make sure that first my website won't go down.
Mhm.
That's the reliability that we were talking before, that my website will still be able to support all these concurrent users, that scalability and stability. And speed, you want your users to still have a decent user experience. It's probably not going to be the best. It's probably not going to be the same user experience they'll get other days, but you still want them not to have to wait up to, I don't know, 20, 30 seconds, let alone a timeout during checkout.
Right. That makes sense.
Or
Yeah.
even the worst, they're just browsing products. You don't want them to bounce. Sorry, I cut you off there. Go ahead.
Oh, no problem. Yeah, thanks for explaining that. So like that gives me a better understanding of what kind of testing we're going to be doing today. And I didn't even understand testing from a different perspective. Like I'm used to testing on GT metrics and these front end performance options. So it's cool to kind of understand a little bit deeper of like what back end performance testing looks like. And it kind of explains for me a little bit better about what we're going to be doing today.
Cool. All right. So that was my first objective.
Awesome.
Let's see what's on the next slide. Okay, so I just wanted to describe some different types of protocol-based testing or load testing. I like to think of load testing as the greater category. Some people will argue with me about naming. There are far too many names for far too many different types of tests out there. It really should be regulated. I just wanted to make these 4 basic categories, if not, I don't know, absolute names for performance tests on the server side. Load testing. Okay, just running an X number of concurrent users over time with this certain test plan that we mentioned before to try to simulate a normal expected situation of traffic, like day to day, or maybe you're changing a provider and you want them to do capacity planning. I would ask for this information for load testing based off the slide. Stress testing is the same thing, but we try to break it. It's pretty simple. We see where the breaking points are, we push it to its limits. Stress testing proposes an actual problem for the infrastructure doing the performance tests. So you mentioned before that there's a server and it's making a bunch of requests. Well, one server can't handle, I don't know, an infinite number of requests. That's where more servers and more resources have to be attributed to the testing platform to make stress testing possible. So you need multiple servers working in a sort of distributed kind of sense. We have more time to talk about that later while the tests are running, and we talk about the infrastructure that we use at Pressidium. Spike testing, sudden short burst of traffic. So you might have a campaign going on, or you might have a TV commercial of an upcoming product, and you might expect, I don't know, 500 concurrent users within the time frame of 5 minutes to be DOSing your site.
Yeah.
And you want to see how your provider or your website, again, objectives, are we testing the infrastructure or are we testing the code? Or not necessarily the code, but the files.
Right.
That's testing. I don't know if I need to go into more detail for spike testing. They're literally spikes.
Yeah. Yeah, I think that makes a lot of sense. So they're just different types of like we're doing our load testing, our general user load. Stress is like what's our max general of what we can handle, and then spike is like I'm going to promote my site on the news, and so I'm going to expect a ton of users at once. That makes sense.
Yeah. And then there's endurance testing. In endurance testing, you try to find problems like, I don't know, long-term memory memory leaks or resource overconsumption over time. So you can have one test running for 3-4 hours trying to test your app or website. In our situation, it's website. Yeah, that's all I have for that. Any questions so far?
No, I really like how you're breaking it down. It helps me as an end user understand just a little bit more about like the key components of what performance means. And I love how we're doing this series of like we did our first series about the components of website hosting, and now we're diving in a little bit more to the testing phase and really breaking down like what does testing mean, what does performance mean, and how is that important to our users as end users trying to build WordPress websites with LifterLMS. So this really makes a lot of sense for what type of testing we want to have on the back end and what we want to make sure our web hosts are doing, like Pressidium.
Yeah, that's all very spot on. Let's move on to the next slide. Okay, so I talked about test plans. We're getting into the juicy part where we're actually going to run the tests. So for anyone watching, I promise it's going to get more fun soon. I created 2 different tests. They both use the same test plan, but then I changed the type of test it is. So again, the first test is going to be benchmarking a LifterLMS website, plain vanilla installation, version 6.3. And as Will said, the latest version of the LifterLMS plugins, including all the extra plugins, not just the primary, the main one. I created a test plan that's going to run this routine. So the virtual user is going to go to the home page, wait a certain amount of time, go to the registration page, submit the actual registration. They're going to push the button, push register, go to the courses page, login page, and so forth. I don't know if you want me to read through all of it. I'll just go over it. So the user, after logging in, goes to the courses page, starts a course, goes into the course, takes the course, like goes through the course, and does the quiz at the end. Submits the quiz, and then the routine is over for that particular thread, that one particular virtual user. And it happens over and over again.
Cool. So then this would be like we're going to have like one server basically sending a bunch of fake users running this routine to our website to kind of test it at the same time. So this is like the concurrent user type thing. Each user is doing this routine.
Yep. And there's multiple servers doing it because of the distributed setup. So it's a whole set of infrastructure with a couple different layers, but I'll get to that stuff during the actual testing.
Cool.
Cool. It's important to note that for each and every one of these requests, there are embedded content requests. So when you visit a webpage like LifterLMS.com, you're going to make requests out to maybe Google API for fonts, maybe for the Google Analytics, Google Tag Manager, and all your sites, JavaScript, anything that's involved with scripting or styling, CSS, all that stuff is going to be requested after the initial page, lifter.com, LifterLMS.com is requested. Like your browser is going to go find that in the HTML of LifterLMS.com, and then it's going to say, "Oh, I need to get this and this and this and this and this and this." That stuff is tested with this kind of testing, the protocol-based testing. What's not tested is rendering those scripts and styles and getting timings for stuff like that. It's important to only include resources that are hosted on LifterLMS.com in that example. So resources that are literally on the server hosting the website. If you don't want to be bringing in images from a CDN, because you're not testing the response time of the CDN. Plus, it's going to end up costing you a lot of money with all the requests you're going to do to your CDN.
Right.
You also don't want to test Google API. Go ahead.
Just so I understand, you mean like, so if we had a video hosted maybe on Vimeo and it's embedded on our homepage, we're not looking at the response time of Vimeo loading in that video. We're just looking at the HTML of our website requesting that resource. Okay.
And just to make that point like really clear, I'm going to try to be brave and do this on the fly by going to Pressidium.com with my browser, opening up the dev tools to bring up the network tab over here in the corner. Maybe I'll do something like this. So we don't want any of these requests. CDN, 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 CDN. Those aren't going to help us.
Yeah.
Fonts.gstatic.com, that's not going to help us either. Google Tag Manager won't help us either. I shamelessly use ad block, so it's blocked.
Yeah. Okay, cool. And so that was what we just took a look at was in the developer tools of Google Chrome. You can see things that your network is loading in from different parts of the web as it loads your web page.
Yeah, going into the network tab. When we do, which I really want to do a call about front-end optimization, we'll talk about the Google Chrome rather than Firefox's dev tools, how the network panel works, how the coverage panel works for analyzing CSS and JavaScript to see how much is used or unused. Anyway, I'm going to get way off topic, and we're at the 20-minute mark, so we have to start doing some testing, if you don't mind, if you agree.
Absolutely.
So the first test we're going to run is going to be something like this. It's going to be about 10 minutes long. I can't know exactly because of the pseudo-random think times in between certain requests. We're just going to go from 0 or 1 to 250 users over. It's probably going to take about 7 minutes for like that to actually happen. because at the end we're going to sit there and wait for 2 minutes.
Okay.
And then we're going to cut those users off at 2 users per sec. And I'm going to explain why while the test is running. Because I think I'm going to run out of things while I'm I think I'm going to run out of things to say while I'm running the test. Those are my neighbors. Hello, neighbors.
No problem. Okay, cool.
All right. So we might get some errors because I'm human. And that's a really good point, too. Online testing tools that just don't show it for performance testing, this kind of performance testing, where you tell the service to run a certain amount of concurrent users. I've used a few in the past. I don't want to be like mean and say they don't work. I'm sure they do, but it's really confusing when you see something with hundreds of thousands, maybe even millions of requests, and you don't see a single error, like a backend error that has to do with the infrastructure running the performance test, right? You don't mind if I smoke? I smoke. I'm sorry, viewers. I hope I'm not offensive. Not seeing any of those errors in millions of requests is just weird to me. So I really hope we get some backend errors, and I really hope I can show you how I can display them here and how I can take them out of the results just to not skew the actual results. But I'm going to be totally transparent.
Okay.
Can't really hide anything at this point.
Yeah, no problem. And so, do you think you could explain a little bit? I mean, maybe when we start the test, about what these, what we're looking at on screen, and what each of these items means?
Yeah, we'll go through the panels. So right now we're looking at the result page. We use Grafana to do this. Anyone that's kind of geeky has already figured that out already. For displaying all the results, at least. There's the test engine layer that I mentioned before, and then below that, there's the data collection layer, where all the results are collected, and that all goes into something that I call the database layer. The database layer is accessible by the Grafana panel that we can see here, using certain data sources. One of them we actually had to kind of not write on our own, but we had to figure out how it worked, reverse engineer it a bit for it to work. But anyway, everything got up to par. Everything's working.
Nice. And so, is this this isn't something that users usually have access to in the back end of a Presidium account, or is it actually a panel for like testing your own website, or is this just something external that we're going to use just to get a general idea of how it works?
This is all built by the Presidium team. It's
cool.
part of our backend, I'd say. We don't users can't actually access what we see right now. It would be nice for the future for them to be able to access the panels for performance tests, but right now what happens is we might have some new upcoming user or prospect that's interested in hosting his website at us, so we'll offer capacity planning. The second test that I'll run today. Well, not quite the second test, but anyway, that's the type of test.
Okay.
And then we'll run the test and provide the user with or the prospect with a report, like saying that this is your website, this is the test plan we ran, and these are the graphs, and this is what they mean, and this is what plan you should use on our work platform for optimal performance to fulfill your needs. Because like someone might be okay with their website, like loading in maybe 3 seconds, 4 seconds.
Mm-hmm.
Definitely depends on, it's the whole, the first part of the planning. Make your objectives clear.
Yeah, that makes sense.
So right now we ran the first test. Here's a little reminder of how it's going to happen. And let's go over the panels. Let's see what we've got. I don't know if there's any value in just like going into every one of these, but here I'll just try to paraphrase as I go, like ChatGPT. Total request, it's obvious. Maximum number of computer users running at this point. That's what's on this purple line in this graph too. Response times are very important. This mean response time value is for the entire test. All this information up here is for the entire test, whereas you can zoom into certain parts using Grafana to get the mean from this time to this time, but that's different. Minimum response time, I don't have to go into. Success rate and error rate just really look pretty there, don't they? That's why I added them right there.
Yeah.
Error is the same as error rate. Well, error rate's a percentage. It's an overall percentage that we include in the report. Throughput has to do with not network throughput. It's very important to know it's not network throughput. It's the throughput of how many requests per second are being pushed out of our testing infrastructure to the website. So the test started right around 2:30 UTC, And if you, I don't know, hover your mouse over the line, you get to see how many requests per second are going out at 50 concurrent users. As a general rule of thumb, as concurrent users increase, your requests are probably going to increase. There might be little spikes. It might go up and down too. That's normal because of trying to simulate real users. But again, this is for benchmarking. So for this particular test, it's just going to go straight up, hold, and then not shut off right away. I'll tell you why later, but gradually stop.
Okay.
The second graph is, oh, I'm sorry, go ahead.
Okay, so like just so I understand a little bit more about how this graph is working, we're slowly increasing the amount of users and concurrent users on the website as well as requests. Is that those two lines? Okay.
Yeah, so there's threads of concurrent users running, and those threads are executing requests based on the test plan that we went over before.
Very cool. Awesome.
And
All the way at the top there, if you scroll up a little bit, we
Sure.
see that number 140, 142 max concurrent users. So at some point, we're expecting this is going to like max out and crash. Is that kind of the idea? Once we hit like a certain number of concurrent users and requests,
The site or the test?
just like the test is going to like show us
No,
like
so the test is going to keep running. The concurrent users are going to keep hitting the site, even if the site can't handle it, or even if the site goes down. The infrastructure doesn't really care.
okay.
We'll get a bunch of errors, and we'll get to see the errors. There's an error panel that describes the errors too. But the test is just going to go all the way through this routine right here, and whatever happens, happens.
Okay.
But yeah, so as concurrent users do go up, requests should go up. There are circumstances where they don't. That's different. The third or second graph here, I added the response time here. So it's the same thing as before. There's concurrent users over the number of requests per second going out, and the response time of those requests. And here we're looking at the full request. We're looking at the parent request. So if it's LifterLMS.com, that includes all the embedded content. So everything has to get loaded, and then we get the response time, because we don't. I mean, as a user, you don't really care if this CSS styles for the website are going to take long. You see the end product.
Right.
So here, like at a quick glance, you could see 100 concurrent users. We're pushing out 800 requests per second, and there's a 369 millisecond response time. So all those files get downloaded at 369 milliseconds. Then your browser renders them, and you have a web page. Okay, so there's two little graphs for successful requests and failed requests. So far, no failures, which is concerning. I like failures. It's room for improvement.
Yeah, for sure.
That's the summary panel or tab. I don't know what these are called, separator, whatever. Then it gets kind of geeky. So everything from in this section has to do with response time and only response time. This really big, confusing report just shows you what request is being made, how many of them, mean, median, and modes for them. The percentile, so the 99th percentile had this response time in seconds. The 95th percentile had this response time, minimum, maximum, and more math stuff that we're not going to get into on the call. But it's important. Okay, it's important at the end of the day. It just has everything in one. It's good. It's really bad for maybe analyzing, but it's really good for understanding what happened.
Right. And so
the over time aspect here.
Right. And so if we were to have like a spike in performance, or like, I mean, we're doing like load testing right now. So we're seeing like different users have different user experiences. And so by taking a look at the 99th percentile, it's going to be, so the 99th is going to be like the slowest end of it. So we have like 95th and then before. So like the 50th percentile would be our users at about the 50% mark who would get a faster response. And as we slowly increase up to 90, 95, they're going to start to get slower response times.
From an end user point, from a really technical standpoint, is that no two requests will ever be alike, ever on the planet, ever. So it's always good to try to exclude, like if the 1% has response times of, 5 seconds, but you're at 300 milliseconds, I don't think you care. I wouldn't care. Something happened, network oriented, something happened between the computers, the person's computer all the way out to his provider, the internet, the service provider that the website is hosted on,
Right.
and that. So there's a lot that can happen in between, especially. So region is really important. I guess it's good to note now that you've made that question. It's really important to note that you want your website to be hosted as close to your user base as possible. There's lots of ways you can make that happen, or you have multiple regions, or use something like Cloudflare for the caching aspect of the CDN, I guess. Having your site cached in multiple areas. I'm going to stop going on a rant now
No
because we're
problem.
getting more interesting results. So we're getting some higher response times. And my question is now, do we have any errors? No errors. Cool. Oh, we made it to the peak of the test, actually. So we're at 250 concurrent users. So maybe simulating something like university exams. For a university that could have been using LifterLMS. I mean, there's a 10-minute, there's an 8-minute, actually, ramp-up period. So that's all those users logging in and trying to access the course or the quiz. Does that make sense? I mean, I'm trying to make a real world scenario for what it would be like for someone using LifterLMS, but I think I need your help here.
Yeah, I think that makes sense. So if you're hosting maybe a university or a class that's based on time rather than just like users log in whenever they want, if there's a specific like deadline for a quiz, we might see a lot of users logging in at that certain time to complete the quiz. So this is what it looks like with, correct me if I'm wrong. So you'd have like, we're maxing out at about 250 concurrent users. So that's 250 people on the website at the same time taking a quiz and going through this user flow.
Yes.
Okay.
And repeatedly. With those break times in between. Otherwise, the request per second would be at the tens of thousands, I think. How high have we gotten now? Oh, I shouldn't close the panels. Every time I do, they load. 1.5 thousand requests per second. Yay. At 1.5 thousand requests per second, LifterLMS on the environment that we described before has a 1.25 second response time. And that's the results are aggregated into 10-second intervals. That's something I can change just by changing this number right here. Maybe I'll do it later after we finish the panels. Mm-hmm. But that's good, isn't it? What do you think? The max was right here, right when it peaked, 1.9 seconds. It's not bad. And what's important to note here is the concurrent users were the same. So you've got a lot of load. You've got anywhere between 1.69 thousand, so 1,700 requests per second to 1,500. Mm-hmm. And response time is pretty steady at 1.3, 1.9. Sure, there's a huge increase. I mean, your breaking point somewhere around here. Mm-hmm. For the infrastructure that it's hosted on. Maybe while I run the second test, I should have done this earlier, actually. Talked about what this site is being hosted on right now on our end. Note for next time or for later. We did get some errors. That's fun. Let's go see what those errors are. Oh, here's what I mentioned before we go to the errors, I guess. There's going to be a lot more. I'm just going to stop trying to make a schedule or a program in my head. This is what we were talking about before for the percentiles. So you don't necessarily want to focus on what the 99th percentile experienced or the 1%.
Right, because that 1% is like right at the top, right before it crashes, or right before issues and errors start to be thrown. Is that?
Yeah, and it's at the 300 concurrent user mark, or the 250. I'm sorry, the 250 concurrent user mark too, and then it falls, and then it's stable. It kind of bounces out, which is really good in just 1 minute. So after peaking, the infrastructure handled everything successfully, so that it could balance it out. There was only 1 minute of more intense stress. I don't know. It's really relevant. I mean, if you compare it to I'm pointing at my monitor like an idiot. If you compare the main response time of 300, 400 milliseconds to 1.9 seconds, sure, it's huge. But you've also got to take into account that we went from 1,000 requests and climbing, so they weren't held there for very long, to 1,800. And then there was hold, which is still good. Like, I like this test. This was a pretty good one. So Grafana, it keeps refreshing. And I'm just going to select this part of the test so it doesn't go away. There we go. Everything's going to reload now. The bar graph on the side illustrates the same thing, but in the form of a cumulative bar graph. So you know that 80% of your requests were under 1 second, and so forth.
Okay, very cool.
I don't know if I need to go too much into detail.
And when
for-
to clarify, like what a request is, that's just like loading a web page and getting the resources for that single page. Is that right?
For everything that we've seen so far, it's yes, LifterLMS.com, including all the embedded content that's hosted on LifterLMS.com/something.
Okay. Very cool.
Again, no CDN stuff and no external third-party resources.
Okay. And those other resources would be accounted for when you do a front end test with like GT metrics.
Yes, but why they're excluded is important. We can't optimize them.
Right, yeah.
I can run the test doing it that way too, just for a different objective. It wouldn't be site benchmarking because it would involve the third parties.
Right, because there's nothing like we can do as at LifterLMS.com. We're hosting on, I think, Pagely right now. There's nothing we can do to like make Vimeo faster to like load our homepage video. It's going to be on them to do that. And so this example,
GT metrics, page speed insights, web page speed test, all those tests that use Lighthouse are still important, because what we don't do with this kind of testing is we don't render any of those scripts or styles. I keep saying it over and over, but it's really important. So your site's not going to actually show up in 3.65 milliseconds, but you should be able to open your dev tools, and there's a little thing that I'm going to be brave again and try to do this. I don't think it's that difficult though. So if I open DevTools and go to Pressidium.com, Pressidium.com, was it 1-0, not the C? This isn't going that well.
No problem.
There we go, open this, this is ready, enter. This is what we'd be looking at, but again, without anything that says CDN. So I guess I could do this. Sorry, I didn't think of doing this, and it's a really good point to show. Oh, I was hoping that I'd filter it and this would change, but it makes sense that it wouldn't. Anyway, this is what we're looking at.
Okay, the finish time.
But without all the CDN stuff.
Right. Okay, very cool. And so like you said, that finish time is going to be like once your HTML is loaded, then it starts to request all these other resources and load those in, like your embedded Vimeo, maybe your CDN images or whatever. Like it's going to load that web page, that HTML first, and then start to request these other files. Is that right?
Yeah. Actually, I'm starting to doubt myself for what I just said about the DevTools. I'm not sure either. I got caught off guard.
No problem.
But I'm happy to continue talking about the next panels. So the next ones, they don't include, this is what I meant before. So every panel that we saw so far only had the primary request, right?
Yeah.
With all the embedded content and everything. Now we get to go into each different request. So we can see that registration, which is an uncached request. So it can't be served from our adaptive caching layer, which in our situation, it means it goes past the front end. So we have the first server array in our end tier architecture that does all the caching, and it does the first of the security stuff. And then there's the backend layer. I guess we can call it an app layer, internally call them apps, where there's a web server, and anything that can't be cached comes from the second tier, right? Then there's the database layer, and that's all. Requests that require something fresh or something new from the database, or requests that are posts or logged in user requests, for the most part, are always going to end up surpassing that first layer that does all the caching with the, actually, it's a pretty cool cache. I'm going to talk about it. It's it has two separate layers as a cache. There's a layer that's in memory, and there's another layer that's in SSD. Most sites fit in the in-memory part, so the SSD part isn't used, but it's required. It's there for high availability within a high available setup for caching. I just made it sound cool.
Yeah.
So
when you say caching layers, these are going to be like dedicated resources from the server to like store certain information so it can be served faster. But then there's other information that can't be served faster because we need to talk to the database, like user registration. Like we have to go log it, what their email, what their password, their name is, so we can't cache that. Is that right?
Yeah.
Cool.
Yeah, there's an asterisk here because there is content that you can cache in very specific ways if you know your website well enough, even when a user is logged in.
Right.
But generally speaking, logged in content is not served from the cache.
Okay.
So there's like 10 minutes left in this, and I'm going to just start the second test, but still go into the panels using the results from the first test. What do you think? Is that okay?
That sounds great.
Let me just push some buttons here. Just so we're not losing time.
Oh, no problem. Yeah, it's super interesting. I'm super invested in like learning about this. We're already 40 minutes into the presentation, and I'm like still learning a lot and interested in how this backend performance works, because it's new paradigms and new concepts to me about the front end versus backend testing, and how there's different types of tests you can run and different things you can optimize and different things you can't optimize. As someone who's hosting a website, and it's cool to understand these in a breakdown.
Yeah, that's good. I'm happy. I'm happy it's not boring, actually, but let's keep going. This is what I mentioned before. So with all these little requests, or these requests with a number after them that isn't zero, is some sort of embedded content. So this is where we get to maybe drill down into, if I see a bunch of requests here, for instance, a lot of requests, I immediately know without looking into it that you're not using a CDN, you have a lot of content. I'm just going to assume this, because as soon as you use a CDN or apply a CDN, these requests are going to fall from, I don't know, hundreds to 50. These are really random numbers I'm throwing out. But yeah, this is where we can drill down into every specific embedded content request. So maybe you have one huge JavaScript file that you can sit there and chop up.
Mm-hmm. Right, and that's because some of the requests don't even hit the server. They're just going from the CDN to the user. Is that right?
Yeah.
Okay, very cool.
Your browser makes a request to the CDN path and gets all the content from there, so you're not stressing out the server too much.
That makes sense.
Some more fun graphs just about the response codes you'll get. So 304s, that's when the browser cache is caching a certain web page, and there has not been a certain change on that web page. Like it talks to the server and says, hey, has this changed, this website? And they're like, no, you could use the one that you have in your cache. And the browser's like, cool. And so it pops up quicker. We do in the test routine, it's good. It's really, and unless you're trying to test something very specific, you should use browser caching. Per thread and per iteration. So every time one concurrent user, one virtual user goes through the test plan, the cache should be cleared and it should start over again.
Okay, so that
W2s are redirects. I'm sorry, go ahead.
Yeah, so I just want to understand what you just said about the cache gets cleared when the user is done. So that way, like it's more accurate in the request because we're not using cached information that user has done before when they do another test. Is that right?
Yeah.
Okay.
Yeah. So the browser cache just keeps it.
Okay.
Errors. We do have some other errors, so I'm happy that we got some backend errors from our infrastructure. I don't know how many there were. If there are very many, I won't be very happy. Oh, I'm sorry. I guess there was just one of each. Yay. At the end, there's the details for whatever error you had. If it's some sort of HTTP-oriented error, you'll get the whole HTTP request, or response, rather, and you'll get the HTTP headers. Mm-hmm. And I think that's it. Oh, no, wait, there's the network tab. So the network tab has these 4 tables that are network-oriented. Yeah, network tab. Latency over time is the same thing as time to first byte. So the request goes out, and for the first part of the response that comes back, we stop measuring the time. Connect time is the time that it takes from the time that you push enter on your keyboard until the connection is established. So there's this thing called TCP that does this weird handshake thing. three-way handshake for the geeks out there.
Yeah.
That happens, the cell happens, and then that's what the connect time is. Processing time is the time that the server is doing something until the response comes back. So latency over time, or time to first byte, equals connect time over processing time. And throughput over time is the amount of, or the number of bits or bytes going out and coming in from the client perspective, so from the testing infrastructure, over time. We're running short on time, damn it. But it's okay. I guess we can go to the second test.
Yeah, absolutely.
Cool. Last 5 minutes.
Yeah, and I'm good to go a little bit long if you are. If we need to like go an extra 10 minutes or so to show a test or whatever, I'm super invested and interested in what we're.
Oh, is that an option?
Yeah, we don't have a set end time.
I wasn't aware.
Yeah, as long as we have viewers and as long as we're getting into some good information, I'm happy to go a little longer.
Cool. I can sweat a little less now.
Yeah.
That was helpful. I'll roll the cigarette, have some water, and continue talking about some of the panels that we didn't go into because I wanted to try to get into the second test in time, but now I'll take my time. I just kind of want the whole test to fit. No, I guess it doesn't matter. Aside from the metrics that we talked about, that are all kind of sort of from the client side of things. Well, not kind of, sort of, definitely, just without that browser in the middle doing all the rendering. What's missing from a lot of providers that do this kind of thing is the actual system resource consumption graphs or information. Like, what about CPU? What about memory? What does it look like from the system's perspective? Like, if you go to a third party that doesn't have their site hosted on Pressidium, or even if you came to us with your site that's not hosted on Pressidium, we wouldn't be able to provide you with your system resources to see where bottlenecks are appearing. It's really important as a provider to do this because now we have the full view, the bird's eye view. We see everything. So I don't know. The first example I can show you is that we talk about requests here, like throughput, the number of requests over time.
Yeah.
But that's what the testing infrastructure knows. That's not what the server is going to tell us. The server's information might be different. If it is, you have a problem. Something's not working right in your testing. And fortunately, in our situation, it's not. I really hope it's not. Let's see. Is this going to be Presidium's most embarrassing moment? No. 1.2. Yeah, it's right around there too. The times are a little different, the gaps. But I assure you, everything works. Aside from requests per second, from the server's perspective, we look at the number of Apache connection, PHP processes. Those are FPM workers for the geeks out there watching. Load average on the cluster hosting the website, because there's never, there's that N tier infrastructure that we talked about before, that each tier has a certain number of nodes. For this particular test, we're using our Enterprise 1 plan. It's a 5-node setup. Okay, MySQL statistics to see what's going on in the database while the test is running. The number of connections is on the left, and we've got, just to know how much data is being transferred. That is my SQL traffic.
Okay.
If you notice here, the NTR architecture really shows here, I mentioned it before, the servers that you see here that say LB1 and LB2, so the blue and yellow lines, that's the front end. That's where all the caching happens, amongst other things. But what's relevant now performance-wise is the caching. You could see that there wasn't a significant load on the caching side of things because caching happens really fast and really easy, and it's all in memory, at least definitely all in memory for the LifterLMS website that we're testing because of the simplicity of the website. So that explains the really low load. And that's what, 3 as a load average. We're not going to go into what that means because it's going to get too geeky. At 1,800 requests per second. Isn't that bad for a computer? What That literally means is the computer isn't working much at all.
Okay, so it's just like it's not struggling to handle that amount of requests per second. It's just like the memory is kind of like maxing out. Is that kind of what we're seeing?
Yeah, what was that? The last part, memory?
Yeah, I mean, so when I think of like computer resources, I think of like, I mean, is it like the memory component of the server maxing out, or like just the CPU's ability to handle certain amount
That's a
of?
good question. So load average does mean CPU load average. I'm sorry.
Oh, no problem.
So yeah, it only has to do with the CPU. I just didn't want to go into how it's calculated.
Oh, no problem. Yeah, that makes sense.
So that's why you could see an increase in the app servers. Those are the servers that are doing the backend, the hosting, the stuff that's uncached. So the whole quiz stuff, for example, or the progress reporter in the quiz, or the courses page, everything that the logged in user is doing, those servers do work. And this is usually where we need to put more oomph, like add more nodes in the N-tier architecture for LMS websites. Because
Okay.
most of the important or heavy lifting is done for logged in users.
Right, because there's no caching or other layers that are supporting these requests.
Yeah.
Okay.
Memory usage is going to reflect the opposite of this. Why? Because of what I talked about before, all the stuff that's being cached is from our first layer and the adaptive caching layer, and it all comes from the memory, which we all know memory is super fast.
Yeah.
And compared to disks or even SSDs, SSDs have gotten pretty fast though, but the memory is still faster. You'll see less memory usage for the apps.
Right. And so, kind of for a high level to abstract it out, correct me if I'm wrong on any of this. When we're talking about things like SSD, and like we're talking more about like the CPU and kind of hard drive side of things, where you can store data in the memory component of a server, or you could store it like actually in the SSD or in like the hard drive. Is that kind of correct? So it's more complicated or slower process to access this
Yeah,
information.
your
That's gonna.
computer does the same thing. So when you open the browser and that session, or not that session particularly, but that browser is going to be in the cache. It's going to be accessible faster than it would be if it was loaded from the disk.
Okay. Very cool.
And memory is always faster than loading something from a disk. Or if anyone has, so when I got an SSD, the first time I got an SSD, I just took videos of my computer restarting and sent them to other geeky friends, because an SSD uses kind of sort of the approach that memory uses for disks. Like there's no spinning disk, there's a
Right.
chip. So when you have a hard disk, you kind of wait there, when your computer's loading, even if you do use lightweight Linux. But where with the SSD, you push the power button, it's like memory's above that.
Okay, very cool. But then at some point, like memory is usually more of a temporary resource for a computer to utilize rather than more of a permanent
Yeah,
resource.
generally speaking, yes. But our cache engine, or the adaptive caching layers, the first layer, it handles that. So it's not going to say, "Oh, I'm going to remove things from my memory because it's, I don't know, irrelevant, or because I have too much other stuff to do."
Okay.
If that happens, we have a serious issue. Like we have to fix it. And yeah, no, we don't want that happening.
Right.
Okay, so more stuff about the MySQL statistics. How many queries happen per second? MySQL traffic. Oh, we went over this before. And the last thing is network traffic. So the test is over. I'm just gonna zoom out here and just grab. Up. Stop tweaking on me. There you go. Ooh, we have 90 errors. Exciting. And they're all towards the end too, the errors. Response times this time. So the difference between this test and the other test is we use steps. This was actually one of my colleagues' ideas. Pandos. Thanks, Pandos. This is more for evaluating the system side of things. So when we see an increase of concurrent users, we want to see how the system responses. Generally speaking, there should be an increase of response time for a brief period of time, and then how good your, I don't know, cluster system works has to do with how is that going to get balanced out and how is that traffic going to get distributed. This is kind of shorter than we would do for a client, just to fit into the time for the webinar. Like, to be specific, these pauses, they wouldn't be 60 seconds. They would be 240 seconds. And the increases would remain the same, though.
Okay.
I could show you here. I forgot about this. Fine. So we go up to 300 users. We spend 60 seconds at the peak. Hold time is added now. Hold time is used in a couple different ways. The way I use it here is for how long we keep the number of concurrent users the same. So 60 seconds, and then user ramp up happens kind of complicated. So there's like a 10-second window where we add 5 users.
Okay.
In a 10-second window, every 60 seconds, that's the whole time. I'm using my finger again instead of the mouse. Okay. And ramp down again happens gradually. I didn't tell you why yet, but I will. Well, I guess I could tell you why now. When you have a bunch of requests going out, if you just cut them off like a knife, you're going to end up with timeouts or like huge response times, because you will end up, maybe not, but you probably will end up having requests that have been like sent out from the testing infrastructure, like a user's computer.
Yeah.
And it's going to get cut right there, and it's not going to get a reply. And I don't filter out these kind of errors, because I don't filter out errors, generally speaking.
Okay. Yeah.
So you would get those. And those might be, because we're looking at the end, so these errors here might be related to that. I'll go check. Let's go see. Oh, I'm rushing again. Before we see, let's see what happened at 300 users per second over 60 seconds on the LifterLMS website. Okay, so 2.7 was the peak mean recorded here with the aggregation of 10 seconds. That's not bad. 1.5K requests per second, and over time. Oh, I'm sorry, I missed this peak. But again, it's at the cutoff, so I want to go see, and it's aligned with the errors. So I'm assuming this peak here has something to do with this error. Is this fun for you? We're literally investigating right now.
Yeah, it's interesting to see how like back-end hosting experts focusing on performance kind of analyze these graphs and figure out kind of what the errors are. And I mean, once you identify these errors, or maybe have a website or have a client that would like a faster load time or needs more concurrent users, am I correct in saying that what you would do is then dedicate more nodes, dedicate more of the technology, or just like, basically, increase the pricing, of course, but then build more infrastructure and technology to support the higher load?
Yeah, like we mentioned before in the previous video, we also have the capability as a hosting provider to dig deep into the actual request itself and single out that particular set of requests, whether it has to do with login or maybe, I don't know, a specific course in an LMS website. And we can attribute resources in the second tier, where all the login stuff would happen, to that particular process or those sets of requests.
Right. So that makes sense. So like what you laid out earlier in the webinar was our routine, our test routine, and it had like, 10, 15 items as to what these users are going to be doing. And maybe during the quiz is when there was a lot of load, because maybe the quiz has 200 questions or something. Yeah, here we go. So it's 15 steps. And then the quiz, I thought, start quiz is one of the steps. So if that quiz is massive, then maybe that's where the choking point is. And so we would need to dedicate more specific resources to loading that quiz specifically. Is that right?
Yeah, I mean, if it's a huge, like if the request has a very large payload and there's lots of users making that request all the time, sure, that could be something. I think it made more sense to attribute resources to the entire course. I mean, you don't lose anything there. You don't want one of the nodes to just be waiting for users to do the quiz.
Yeah.
So it's definitely going to have a share of the rest of the traffic too. Otherwise, it's super underutilized.
Right.
But yeah, that's a crazy example. I really hope it never happens to someone.
I do hear a lot about users who have large quizzes that are about 100 questions or so, who say like it's taking like 5, 10 seconds, 20 seconds for this quiz to load. So that's kind of a common point for our users to run into issues with a web host, is because the quizzes have so much data in them that it's and so much database interaction that sometimes there's some issues with that. at scale.
I wasn't aware of the use case. It's worth testing. That's what I'm writing.
For sure. Yeah, it's like I don't know like when this happens. I'm surprised with LifterLMS as to how creative our users can get with creating huge courses and huge quizzes. But the quizzes and the course builder loading is another common thing, because when you use the LifterLMS course builder, you have sections and lessons, and it's all within one interface, and you can click an expand all button. So if you have maybe 50 sections and each section has 5 lessons in it, now you've got 250 lessons that are trying to populate on the page at the same time, and sometimes this can cause errors. And so that's like the course builder and the quizzes loading are 2 points where I see users at scale kind of have issues.
We can do that. We can maybe we can test that live next time.
For sure.
I didn't know it was a use case. I think that's an error on my end. I should have generally talked to you about what users see so we can apply their specific scenarios to testing, other than, I guess today we're just doing benchmarking. Now we have a second topic for next time.
Absolutely. But this is a really great illustration as an example of, what a general LifterLMS site with all the add-ons is going to look like on your enterprise hosting level at Pressidium with the load testing.
Yeah, that makes sense. Sorry, I started geeking out on my own.
Oh, no problem. Oh, yeah, what are you taking a look at here?
What time those errors? Cool. Everything is uniform, so everything is right in the test. And the amount of errors at the time it happened and the nature of the errors don't make me at all concerned.
Awesome.
Particular, so the results of what I would say to a client after running this test, if it was more legit, like if these spaces were longer and if everything was, it would have been about 40 minutes. It would have been a longer test. And if I would have run the test at least 3-4 times, because one test is never enough. Yeah, I can't stress it enough. One test really isn't enough. It gives you an idea. It's indicative, but it's not as conclusive as it can be. And performance can't, I don't know if it can ever be like 100% conclusive. So run more tests, run multiple tests. But I tell the customer that if they, or the potential customer, that if they did expect a steady amount of 150 or 100 users to stick to this particular plan with this particular website, and if they had some peaks of up to 280, 300, and they're okay with like the 2-second response time, because it's just a huge increase. It's what? 4.5 times, 5 plus. But maybe you're fine with that. Maybe you're fine when it's high traffic and you're at 2.74 seconds. So there's no need to give you more hardware, more nodes, and charge you more.
Right. At that point, it's really a question of, is the customer happy with the load time, or do they think that it would help their business to put more resources into hosting and make it a little bit faster?
Again, this is half the story too. I have to see what happens on the other side of things. I have to see, I hit the mic. I have to see what happens on the browser side of things, because what if some of these files cause rendering errors, issues that make the website load in 10 seconds? I know that everything gets there, and that from a server, from a hosting provider side of things, I'm good, I'm covered, I'm awesome. But if your site is really poorly designed, these results don't say much. So you have to see both sides of the picture.
Right. And that's a super important point, I think, to emphasize, is that taking a look at the front end, and we'll probably take a look at the front end maybe in another webinar or another tutorial, because that's a really important thing, is like when a web host talks a lot about optimization, or you find like a cheaper web host in the web, usually when they optimize things for speed, they're optimizing what we're taking a look at here, which is just the deliverability. But then like by implementing some of these caching or maybe advanced CDN stuff, it causes actual issues on the front end for the user. So it's super important to consider that as well. But we'll probably talk about that more in a future webinar for what that front end load looks like.
For sure. I want to get more ideas from you, and maybe anyone else watching this, maybe they have questions.
Yeah,
I'd like to answer them. Plus, you don't know. Maybe they even have a website. They could bring websites. So Pressidium offers this as a service. Let me get salesy now. Sorry.
Yeah,
we offer this as a service, and we offer it for free for prospective large clients. Like if you come to us with a website with serious load, we're going to say, cool, could we copy it and put it on our infrastructure and run these tests? And then we can say, hey, this happened at this plan, this happened at this plan. We made these changes and we ended up with this result for you based on your objectives, again, what you're looking for. And you could say, we'll sign up, or you could go to another hosting provider.
Absolutely. Well, I guess, was there any other items you wanted to dive into here on the webinar, or do you think we could wrap it up and do our pitch and see people?
I think, well, we ran the test. We did everything. You don't have any other questions for me at this point?
No, I think we're good. That was a great demonstration. Thank you so much, Christos, for coming on and showing me some of the back-end load testing that you guys do at Pressidium to figure out how to optimize web host delivery. And so if you want to learn more about Christos and the awesome work that Pressidium is doing in the WordPress website hosting industry, make sure to go to, I think it's Pressidium.com, right? Yep, Pressidium.com. Or you'll find a link in the description of this video. You'll find links all over our website on our recommended resources page. But Dad, this is a great demonstration. We've also done some other content with Pressidium, and we'll be doing more content with Pressidium in the future. So leave a comment on this video wherever you see it, and we'll write down what content you want to see, and we'll create some more detailed stuff about WordPress, LifterLMS, hosting an LMS, and what you want to consider with a web host to just kind of demystify what web hosting is, how it works, and what you want to consider when buying it. But thanks so much, Christos, for joining me, and thanks everyone for joining us live and on the replay.
Thanks, everyone.
We'll see you next time.